totally recognize that, because I got the dirt bike couple of years ago, starting for a fun exercise.
Yeah.
And going from a street bike to dirt bike, it was kind of a chilling in the backbone when you're doing turns and you start to slide and you kind of straighten it up. And it's like you don't want to have to slide because it's just wrong in the whole body. And it took full year practicing to get that feeling off. And yeah, you need to swallow your pride, and you get overtaken by 10-year-old kids just flying and sliding, and it's good fun. It's good exercise. I like it.
Yeah, I think life lesson I've learned: you never compete with a 10 to 15-year-old kid. You just do not do that. Like that competition is gonna cost you a lot in and medical bills. So. So my, that dirt bike story, it was scary, but I was still on it. I enjoyed it because it's motorcycles, and I love motorcycles. But then we tried the ATVs. Have you been on an ATV, like the four-wheelers?
I just tried it, but since it's so stiff, I like the bikes when you balance, but with ATV, it's too rigid, I think.
And not only that, it's, it looks like it's got four wheels and it's safe. You're like, it won't flip. It's got four wheels. I'll do my thing. Those things are so easy to flip. Easy to flip. And you take one fast turn and you're like, it just kind of tips over. The center of gravity is a little bit higher. So that first year of me coming to States and like enjoying, all the nature and ATVs and dirt bikes, man, I have so many scars from it. Like, I can just, it was a great first introduction to, to this country. And I enjoyed it so much, and I think that's what opened the doors for me to be an outdoor person, love for motorcycles. Like I could have like a very stressful day of it'll be work and this and that. And all I have to do is just hop on the motorcycle, go towards the ocean, just ride it, and just and all the stress kind of just goes away, and it's just a fantastic feeling. I'm blessed to be in a place where I get to do this quite a lot. It doesn't snow down here, so
it's Now last weekend I drove a snowmobile. We don't really have snow here right now, but going a couple of hours up north, there's still plenty of snow, so it's good fun driving a snowmobile. And the whole northern part of Sweden is it's the culture of winter. You need to drive around and get around with the snowmobile. Great. Great fun.
Yeah. Do you have lots of in your backyards that you can just go take the snowmobile out, or do you guys have to go to a resort or something to access?
It is. You are allowed to drive on certain prepared tracks. So it's tracks all over the place, and often it is a local union or people that take care of it, and you pay a small fee to them to maintain there, because they have a lot of mileage to track to compensate for fuel and stuff. So it's pretty diverse of different kinds of tracks, and if you go to the mountains and the high mountains, that's open area, so it is pretty good. I think we are quite successful in Sweden to have that liberty. In Norway, it's restricted; you cannot drive anywhere, so they come into Sweden to drive.
Oh wow! So the Norwegians are coming to Sweden to enjoy all this extracurricular activities, huh?
Yeah.
Oh wow! Okay, all right. Did not know that.
Norway is great for skiing and so on, but not motor vehicles out in the forest or on the mountains. It's restricted for
So they have their things, and then you guys have your things. I see.
Sure.
Okay.
Yeah.
Live in peace and harmony that way.
Now we a couple of 100 years ago, we were not so peaceful with each other. I mean, it's coming back and forth. I mean, we've been in a union together also, so it's more on that terms in the last 100 years, 200 years.
Yeah. Well, a couple of hundred years ago, I don't think anyone was friendly to each other.
Now, looking at the history, it's been going back and forward.
Thank God we're past that now. So yeah, and I think it's right about time that we start this as well. So yeah, let's get started. I just can't wait. So Good morning, good afternoon, and good evening to all our viewers that are tuning in from around the world. We are extremely excited to have you guys over here, and we've got a very exciting episode, in preparation for you guys. So, welcome to Live Design. We are coming to you live from our new 3D Experience YouTube channel, and make sure to like and subscribe if you haven't yet already to get the latest and the greatest content that we post on this channel regularly. So. Talking about content, if you have a LinkedIn account, or you follow Dassault Systems or SOLIDWORKS, you must have seen some very cool simulation animations pop up on your screen on LinkedIn, and that kind of points me to our, I'm going to invite our guest for today's live design episode, Matthias Robertson. Please welcome Matthias. How are you doing today?
Oh, thank you. Oh, thanks for having me and inviting me. I'm good. Thanks. How are you?
Hey man, we are fantastic over here. For myself, I'm very excited to see what you have in store for us. A little bit of background about me. I'm Ronan Mukherjee. I'm an industry process consultant here at Dassault Systems, and I'll be your host today. And Matthias, please, would you mind giving us a little bit of introduction about yourself and where you come from?
Sure. Yeah, sure. I'm based in Sweden. I'm born and raised in Sweden. My background is a mechanical engineer. I'm not a simulation specialist, just to make things clear. So I'm passionate about simulation, but I'm not trained in this simulation area. So just regular mechanical engineering. That's my background. I worked a little bit at ABB before I entered this world of SOLIDWORKS back in 1996, actually. So that was SOLIDWORKS version 2, SOLIDWORKS 96, where I joined as a reseller. So I've been working with SOLIDWORKS since then. I've been a technical manager for SOLIDWORKS in the Nordics and Junior North since the last 20 years. And in the last 3 years, I focused 100% on simulation. I've been carrying the SOLIDWORKS portfolio and electrical composer, not so much PDM or CAM. That was not my strength, but mechanical engineering and simulation goes hand in hand, and I really like it. So that's why my passion is.
That's a fantastic journey. So let me ask you this one question, because it kind of reminds me of my ideas too. So. You said mechanical engineering, goes hand in hand with simulation, and it's great. And it's, I do the same thing. Why not PDM? Like, why would you? Was that something you were like, hey, you know what? Let's put PDM to the side and let's just kind of focus on simulation that's
the situation we had with the resellers, because they were so knowledgeable about PDM, so we didn't have to support them. And also from Sweden, I don't know if you know the history of SOLIDWORKS PDM. It's coming from Sweden. So the Swedish reseller or the Nordic reseller was very up to speed with the SOLIDWORKS PDM when it came into the portfolio. So we didn't need to support them in that. So it was self-carrying, and they really picked up the knowledge in that. And yeah.
That's great. That's great. So one more thing I want to mention to our viewers, we want to keep this episode very engaging. So the live chat is on. Please drop us your comments, your questions as we move through this episode, and we'll do our best to answer all of them, most of them. And if there's something we miss, we'll definitely get back to you guys on that. So Matthias, without further ado, let's jump into what you have for us today. And I just can't wait, man. I'm like, whew, I'm excited, as you can tell. It's like, please, stage is yours.
Yeah, I mean, we have a lot of things that we can discover and explore, but also, as you said, we really want to have some input for you guys from the chat. If there's any topic or like engineering challenge that you want us to address, we can explore that a little bit more. So I'm prepared to talk about anything, basically as long as my knowledge is there. As I said, I'm not a simulation specialist, but I see what I can do. My strength is probably structures and fluids.
Hey man, those animations that we see on LinkedIn, that speaks that says otherwise. So
yeah, but that the history from that is kind of being and still is my learning experience. I'm get really excited about some feature. I think, oh, this is really cool, and I just pop it out. And it's not so much thought behind it. I think I get more concerned about how it looks and how to set up the video now. But in the beginning, it was just cool feature, and then put it out there, and then it got more exposed, and I was like, okay, I need to shape up the look for things then. So
that's great. So let's do this, Matthias. We've got a lot of viewers that are joining us. How about we ask them what engineering challenges that they run into, on a daily basis while working on their product development process. Let's see what our viewers have to say about, like, what are some of the engineering challenges. What do you think?
Yeah.
So yeah, guys, if you have any engineering challenges that you guys face, please put that in our chat window, and we'll take a look at a couple of these.
Yeah, so there's a lot of challenges you can run into as an engineer, not just for mechanical engineer, but I think most of our SOLIDWORKS customers are in mechanical engineering in somehow, and everything that comes close to mechanical engineering. It could be thermal, it could be wind loads, fluids, vibration, anything. So just to emphasize how many engineering challenges we have that we can address with simulation, it's great. And I would say in the last 2-3 years we have more simulation products that can address even more challenges that we haven't been able to do before.
Right, and from what I'm looking at, Matthias, the design challenges they're spread across the board. They're just there's quite a lot of challenges that we will run into when we are working on the product development process. And I see some of these over here that I personally have run into quite a lot. So that's thanks for sharing. And so let me ask you this. We've got design challenges. Everyone has those. And so where does simulation fit into these challenges? Like, what's the value that simulation brings to our users and engineers and product development people?
Yeah, so I think it's really a good question, and that's often a question I ask companies. What really put ourselves on and as the companies and the user side of you, what challenges you have and what drives your product development. Not going into specific detail, but there's a lot of drivers that simulation is a key tool to use if you want to increase the performance or make things stronger. If there's some noise reduction, use the material in a correct way, or new innovative ideas, make things lighter, improve the quality. Are there any safety concerns? Is there any risk involved? Is there people? Always price and the cost is the driver. Even if you say that we don't have any innovation, we don't have any new products in line, but what about your existing product? Can we lower the cost? What's the price of that? Can we look at alternative material manufacturing methods? So sustainability is a big driver now in the simulation area, or I would say use simulation to address that.
Right,
it's always time to market. Yeah.
Right. Sorry for interrupting. Especially with the whole world trying to go green, and this new green initiative, that eco-friendly sustainability aspect from product development is incredibly important. So thank you for bringing that up.
Yeah. And it's always time to market to speed up the development process. I've seen so many companies that really reduce the whole development time, but also some companies say that but we have the same development time, but we have a much better product at the end. So we spend our quality time making sure we have a better product. So the time to market is not over there. It's depending on the product, of course, and the industry you're working with. The printing manufacturing process is kind of the new in the last years, really picking up. Energy, the energy cost is not going down. There's no reason that those costs is going below. It's going to be going up and up.
Absolutely, man. Trust me, I checked my electrical bill yesterday, and that was not a fun one, So I know what you mean.
Yeah, and welcome to Sweden and tank your car. I think you will get surprised there. So yeah, Other things that could be addressed is like heating and cooling problems, and also regulations. There's a lot of standards that needs to be followed, and using simulation is kind of verifying you're doing it correct. You might need to do physical testing at the end, and just to make sure that you're within the scope of meeting those regulations. Operation problem, and also the trend in the last years of being connected with Wi-Fi, with having access to your device. So and that's kind of where mechanics and electronics meets, and you need to have a good antenna and how that is connected to the Wi-Fi.
Right. Yeah. So this is a lot of good points that you bring up here, Matthias. So let's talk a little bit about what the old school product development process was. Where and you mentioned a few things where we've got a design engineer that designs something, then you kind of go ahead and you make a prototype out of it, and then you bring that prototype and you do a physical world testing, and then of course it'd be great if we can all get a great product in the first try, but that's not how life works. So then you have to go back and make changes and do it X amount of times, and then you get a final product. But whereas you mentioned with simulation, you can cut down that the iteration process, the X amount of times that you are making design changes and simulating it in real world life. You can cut that down by just doing it virtually, and then doing one or two physical tests to kind of confirm the results with the virtual and make sure that you're going in the right direction.
Yeah, and I think that's important. That often we say that you can reduce the number of prototypes, and that doesn't mean that we are completely eliminating prototypes. I mean, it often is that you need to do a prototype, but the number of prototypes and the iteration to get a good product, that's something you can do virtually with simulation or virtual testing, as we can say. And I think often we talk about simulation, we often use these very general values. And I think for a mechanical engineer, I put down 10 points, and I think as I would like to address benefits for a mechanical engineer to use simulation to help you size and dimension to use on a design, just to make sure we're using the correct material thickness on the certain parts, test new ideas, meet specifications. What are the requirements that you need to fulfill, and how can you meet them? And this is something we want to do virtually, and make design decisions. Should I do this? Should I do that? And improve the design by doing a lot of iterations. And once you started to use simulation, you don't go back, because it's so critical engineering tool to help you and rely on the results. And they, of course, could increase the performance and reduce the cost by doing that, and the quality. And also communication. Simulation is a great tool to communicate to other stakeholders, other members in the product, but also for customers to show that you have really tested your idea, you've really verified it, and this is what's going to happen, and show the physics or what's happening with the products in front of customers. So many companies use simulation as a sales argument to their customer base to show that they are, in the higher quality, that they really thought about everything there.
Oh, that's fantastic. So, you do bring up a lot of good points over here, and it kind of, I have a question that's, it's sticking in my mind. So this tool simulation, who should be using this tool? Should this be an early designer, or should this be a PhD level mechanical engineer, master's level mechanical engineer, or your engineering manager? Who should be working with simulation at what stage of the design?
Yeah, that's a good point. Also, we often see that. It could be from a concept phase when you try new ideas and be really creative, and I think everybody can use it. It's not complex, but the fear of simulation is to do something wrong. And can you trust that you have done something right, and can you trust the results? So training is always important to get, and do that from a reseller. it's a constantly process to tweak your design to set that up correctly and to trust it. So use it for concept design and also for regular mechanical design when you do the size and dimensioning to see the result that you're doing the right thing. It's kind of support your gut feeling. I mean, as a mechanical engineer, I know if I make something thicker, it will be stronger, it will stiffer, but how much? Where's the weakest point? So it's a guidance tool for product development in general there. And
awesome.
Also, yeah.
No, that's fantastic. So we've got one of our viewers, Mohammed Saad Khatri. He's got a great question for us. And this could help other other users as well, or viewers as well. So what are some of the good resources to learn about the product development cycle on SolidWorks? So would you do you guys have some resources at SolidWorks? I mean, I know that I just hop on YouTube and I just Google product development and I'll just pick a product and see how it's made, and it's just the curiosity I have. I just want to know how things are made. That gets me in trouble sometimes too, because I open things up and then I can't put them back together. But would you have an answer for our guest or our viewer Mohammed? Where can we learn a little bit more about the product development process?
Yeah, it's there's a lot of sources to learn from. I mean, YouTube is a great source of everything, but it could be hard to filter. We have our own kind of community called mysolidworks.com, which is open and free for everybody, where we kind of have more SolidWorks content that you can learn from, get started in different areas. But also contact your local reseller to help you specific trainings in certain areas. So I know more and more people would like to do online training, and we have a lot of content online, but it's not free. So it's kind of what can I get for free and what do I get when I purchase something. So contact a local reseller to get more information and more resources. That's my go-to recommendation also.
Yeah, great. Yeah, absolutely. Like Matthias, you said, what's free, what's not free. I love starting with free stuff. I love free stuff, so YouTube is free. I definitely would start there. And then, of course, like Matthias mentioned, reach out to your local reseller, and they will be able to get you get some more good resources on this process for you. So hopefully that answered the question. So, all right, Matthias, so we talked about the value of simulation and, what challenges engineers can face and what's the traditional versus the new, the product development process and how it can improve the product development process. So let's see what else you have for us, when it comes to the tools. Let's see some cool stuff.
Yeah, sure. So what we specifically address with simulation are 4 different domains. It's structures, it's fluids, that could be liquids, it could be gas, it could be electromagnetics, which is quite a new domain for us in general. And we also have plastic injection molding. So let's dive in a little bit on the structure areas to see what we can do there.
Brilliant.
So not talking about the specific products, but in general, how we can use simulation to help us design products. So maybe if you want to identify forces and loads that occurs in your design, so we can use rigid body motion to help us understand and meet specification. What size of the motor or cylinder do I need? How much force is needed if I need to do the lift in 1 second? So I get a quite good starting point of how I can use the values for my further design, or also test components. If I test this motor with this power, what is the effect? Do I meet my specification on that? So anything that moves in a mechanism generates forces.
Sure.
And those forces we need to take care of. We need to think about, is this good enough for my factor of safety? Maybe I have some fatigue problems at the end. So just to be aware of what is happening in my design and then optimize cycle times and so on. So that's a little bit of rigid body motion there.
That's great. Like as long as, as soon as you've got some, movement happening in your designs, you've got some dynamic loadings happening, and of course the forces and stresses that are produced with that, we want to know if your design is going to be working or not. So no, this is fantastic. So the moving parts and forces that are generated with that, that's a second leg of the simulation, because sure, you can run your first study in a static scenario and see if things are working, but you don't know if it's going to be working on a dynamic side, correct?
Yeah, and also I think this is the starting point of simulation, where you have created your 3D model in SOLIDWORKS or some other program, but simulation brings it to life. Now we can add physics and really see what happenings and things starting to move. And now we just generate the forces. But what happens inside the design if we want to look at stress levels, deformations, and so on. So this is really the beauty, I think, with simulation, really to go in your design and see what's happening. How strong is it? Maybe we don't have strength as a parameter, but stiffness and really the help our gut feeling of what's happening here with the design. So it's really adding the physics, but also thermal. If we have temperature changes, things start to move, and that could also be a factor that we need to consider. There could be quite high forces on thermal loads as well there.
So we can bring thermal loads. We can bring, you can run a thermal study in simulation and bring those thermal loads into our static study to understand how those thermal loads kind of affect the design.
Yes, so thermal loads, the physics are convection, conduction, and radiation, and often thermal. We have that as a fluid problem, because often we have gas or air that we cool or heat with, or some other liquid. So we have two different products for thermal loads, but I would actually recommend fluid simulation for thermal loads. So if we have a look at what we can do with flow simulation, we can really capture the fluid movement of if we have a air or a gas or a fan that is cooling. So the output of this could be an input for structure. So we kind of do this as a two-stage rocket. First, we do the thermal study to figure out what temperature we're going to end up with, and then we do a static study to see how this is deforming there.
Oh, that's brilliant. Yeah, of course, like the effects of your thermal loads will affect, your the design itself. And, of course, when things heat up, things melt. So we want to address those scenarios. So this is fantastic. So you mentioned that for these type of problems for thermal studies, you would rather use the CFD rather than the thermal study provided in SOLIDWORKS simulation?
Yeah, it depends on the application. I would say that 95% I will probably use flow simulation just to get more accuracy and easier to set up. We can do thermal studies with conduction, convection, radiation with Simulation Pro and above, but flow is easier to set up and you get better result. And also the air movement, the fluid movement is recognized here, because it could be the fluid that carries the energy, and it will influence the final outcome there also.
Right, and as I can see with the animation, it looks fantastically cool. Like that is great. I need to learn how to set that up.
Yeah, and that's also what I want to experience that and highlight, that you can actually step inside your model. You can shrink yourself to 1 millimeter and really experience your design from inside and out. And I mean, how much better wouldn't you pay to shrink yourself like an Ant-Man and then go inside your design experience and see what it is? And then you really see what's going on there. You know, the first Xbox the Microsoft did, they had to recall it. They called the button of death or something. It turned red. Yeah. And they had to recall and modify it. It cost like them $1 billion. and because they had a thermal issue, it was not cool enough, and the electronics broke down for that. So temperature is a concern.
They did not run simulation. I'm just kidding.
Yeah,
but yes,
somebody cheated in the development.
Somebody cheated, and yes, that red light of death. I'm familiar with that.
Light of death.
Just because I'm familiar with that, because all my friends that had Xboxes deal with it. I am a PlayStation guy, so we're cool.
Yeah.
Oh no, this is fantastic. Thank you for showing us what structures stands for, what that role and that application stands for, what fluids. Let's I know we haven't touched on injection molding yet. Can you touch a little bit on injection molding? Kind of tell us a little bit about it.
Yeah, absolutely. So injection molding is quite interesting. When I learn more and more about plastic, the more interested I became, because our decision we make as a designer really influence how easy it is to be manufactured or not, regardless if you think it or not. Because making a plastic tool, there are some things that we need to consider. We cannot make things. Oh, this didn't work. Sorry about that. We cannot make things too thin, because then we can end up with short shots. We need to understand. Oh, I don't have my plastic to work. Sorry about that.
No worries.
So we need to make sure that it's okay to be manufactured. There could be problems with weld lines, that the flow really meet each other, and that could cause problems, visible problems also, and also weaknesses in there. It could be air traps, and these things are impossible to predict unless you have really good experience from other failures and a success, how to meet those. So it really, with plastic simulation, you can really gain 30 years of experience by using simulation, because now you get an understanding what's happening here virtually, and doing changes to a mold tool. I mean, that's super expensive, and it will take time, and it's all about avoiding problem and make sure that your plastic part is suited for injection molding process there. So I think it's a main tool for plastic designers to understand the impact of gate location, the flow front, how things are flowing inside the tool, and also for mold makers to make a good mold layout that is very efficient and also not run into problem, and also cycle times, temperature, pressure, and everybody is of course interested about the warp at the end. How much does it really twist at the end? Because we want to have a good quality at the end, and make sure that our tool has the precision we want to. A lot of plastic manufacturers, they know how to fix things, but often they need to change the process parameters, increase the temperature, you have longer cooling time, and suddenly the cycle time is off. So it's kind of finding that those problems early when it's easy to do the change there. So we really like plastics, and they, can do a lot of stuff there.
That's so beneficial, and we see plastic parts all around us. Plastic's just everywhere, and it's not going away. As much as we want it to go away, it's not going to go away. Hopefully, some more eco-friendly plastics are available, in the future. I know, we're doing a tremendous work in, finding these type of plastics. But you do bring a lot of good points over here. So what I'm seeing on your screen, Matthias, I see, like you say, wet lines and air traps and sink marks and short shots. So these are just issues that we see on plastic products. If we don't have an experience in, like you said, 30 years of experience in plastic products, and gone through 30 years of failures and trying to understand how this works, And we can overcome that with just the plastics, the simulation tool that we have, and at least know where these issues are going to happen. So we can, for example, change our gate location. That will kind of change where the well lights are being created, where the air traps are being shown. This is fantastic. So yes, and there was another point that you brought up, that the rework that goes into molds, that is costly and lengthy. So when you think about it, and another point that you brought is like, the thickness of materials, or plastic materials and stuff. So when you're thinking about a mold, of course, and when you have to do a rework on a mold, either you're removing the material from the mold, or you also sometimes have to add material to the mold. So those things can be tremendous.
And I think, and you bring something up that I wanted to mention, the thickness, the trend in the plastic industry or parts in general, they get thinner and thinner. And as a mold maker, you have your guidelines not to go thinner than this thickness on a certain material, but we're kind of pushing that limit. I mean, looking at the shells on mobile telephones, they are super thin, and we need to make sure that you can do that part, because doing thin plastic part, that's the challenge. But that also comes with the sustainability stuff, that you want to make things thinner, you want to use less material. So how far do you want to push that with your experience? Well, now we can simulate that and make sure it's working.
That's a great point. And that actually asked, we have another question in our chat, and it's a fantastic question from the point that you just brought, how far we can go with this. So question that Maurice has is, how about our future expectations? Will we be seeing like some AI influence in simulation, or have you seen something so far? Have you heard about AI influence in simulation? What do you have to say to our viewer Maurice?
Yeah, that's a good point. So let me find my slide about that. That was not that. There we go. So yeah, I think that's really interesting about the history and the future for simulation, because simulation in the past, if you go back 20, 30 years, it was so hard to use, complex, expensive, and it was targeted for specialists. And the hardware expensive. And I think today we have really gone a long journey with simulation, where it's powerful, it's easy to use, it's fast. We have integration in SOLIDWORKS. It's really cost effective in the product development. So today we have access to cloud computing, a lot of cores that is included with the license. We have GPU computing. And that's what we see. What's going to happen in the future? Well, I think we get more AI, machine learning. We can also see that, and they will probably take a very long time in certain issues, that we can do certification with simulation results. We don't need to go to this lab and make a physical test and break it to get certified. If the industries accept more and more simulation,
that's a fantastic point.
Yeah, and I think some parts in the aerospace industry, you can get certified by showing simulation results. I'm not familiar with that, but I heard that it's coming. So I think that is also interesting in the future, that we can accept more virtual tests and trusted results, and also doing even finer simulation. We have probably more computing power in the future. We can get even faster results, and also do simulation on granular, maybe molecule level, and get even more details there. It's going to be bigger problems, but we can do it in even finer, I think.
I was just about to mention, with getting into the molecular level, of course, is going to open another set of problems which we'll address and get there. But no, this is a fantastic roadmap that you're showing, and and you've kind of nailed it. Like in the past, it was extremely hard to use, and I still remember, my uncle who was an engineer, and he used to, do some hand calculations and stuff, and I was like, hey man, what are you working on? And he's like, oh, this is what we do and all that stuff. And of course, like, I don't want to do this. So but things have come a long way. As of today, like you mentioned, much easier to use, much lots of power, and you don't have to do those hand calculations. Now you've got leveraging the cloud computing power and the GPU computing power to put some awesome results out there. And I'm actually looking very forward to the future as well. And thank you, Matthias, for this fantastic question that you had regarding, if we're going to see AI into this. From our expert, Matthias, we're definitely going to be seeing some machine learning and AI incorporated in the simulation, workflow. So it's going to be fantastic. Looking forward to the future, like always. Yeah, Matthias, I know that, I am super excited for this. So I know you have some cool videos and animations to show us, and of course, introduce, the superhero Bruce. So for our viewers, if, like I mentioned earlier, if you have a LinkedIn account, if you follow SOLIDWORKS, Dassault Systems, you know who Bruce is. So Matthias is the man behind Bruce, and he would give us some. Let's see what Bruce is up to.
Yeah. So Bruce is, of course, the name comes from the Mythbuster. Their test dummy was called Bruce. So I think why don't we have a virtual version of the same and call him Bruce. So the history of Bruce, I show how I create Bruce. This is been on my journey, still on my learning journey. So if I learn some new feature, I want to include Bruce with that. And of course, with a test dummy, you can do quite a lot. So one of my first videos was with the SPH elements. Okay. That's something we have in our structural mechanics engineer role. It's kind of liquid, and it has some forces between those particles. So these are quite big particles. You can see this kind of a snowball. I thought, let's move this to a test dummy and make him blue. I like blue man group, so I want to incorporate the blue stuff there. So I can show you a little bit
so that's where Bruce came from. Okay.
Yes.
All right. That's good to know.
So I can show you how Bruce is created. Now I have just the face of Bruce. But Bruce is created from something called Visual Experience Designer. And there's something called the human design here. Just correct this one up. So here we have a lot of different characters, man, female, and I picked this guy as Bruce. So it is very, very detailed what you can do. I want to share my kind of nice indoor there. And if you want to change the poster, it is fully doable to change the poster there.
Oh, that's awesome. That is awesome.
Yeah, I want to show that it's photorealistic at the same time. So let's add the colors here. So here we go. So you can really change the position and do some workout here at the same time. And it's also super detailed. I mean, it's even the mouth you can open. You can see its teeth and its tongue, and it's all kind of stuff there. So for simulation, I reduce this. I export Bruce and I delete this. You can change clothes, and there are some predefined positions that you can do, but you can do your own stuff there. So I cannot use this directly on simulation. So I export it to SOLIDWORKS, and then I modify it so it can be used there.
Oh, that's a fantastic way to create a virtual test dummy. And now let's see what we've put Bruce through. Thank you for introducing Bruce to us. But let's see what Bruce has gone through over the years with Matthias. That's what I'm excited about.
So this is kind of my I'm adding up more and more feature, more capabilities here. So one of my first simulation was doing drop test with a frame, and Bruce was, I didn't had the color on, I didn't know how to use it, and it's kind of hitting the face. But doing drop tests is so easy, and just to set this up and run it. And I mean, there's a lot of industries that need to do this kind of test. It's kind of falling object protection system. So there are certifications and standards you need to follow to do protective bars and so on top of that.
Right. That's and tons of, like you said, tons of application I can already think about, like when it comes to dropping things and making sure things. So when it comes to that frame, so what type of results are you expecting to get out of those results? Are we looking for displacement and stress results in those bars?
Yeah, and also the final displacement of can it withstand the load, the impact, the energy that comes, and that's the kind of the certification. You need to have a 5 kilos dropping at the speed of, I don't know, X amount of meters per second, and it should withstand. It should not buckle in and so on, and it should not collapse. So it's kind of a good tool to verify and see that your design is withstanding, and also make it stronger so it can withstand overloads and so on. So just for safety reasons there.
Yeah. And also not to drop the block on a real person, wearing a helmet to test physically, because that would not be good if the bars don't stand they're supposed to do. So that's awesome.
So then I learned a little bit more, and I really like the virtual environment where you can have this kind of testing ground, and now Bruce got a little bit more detail. It got eyes and got more some skin colors, and I did quite a bit more job with this helmet design.
This is great. Yes.
To see the impact of a helmet, and doing helmets, you do different materials, maybe some foam. So it could be quite complex material definitions, but with the powerful Abacus solver and the material setup that is very, very detailed, we can really solve this. And it's an impact. It's kind of very dynamic, rapid simulation here.
Right. And just to kind of think about the applications of this again, I see all these cool simulations, Matthias, and I'm only thinking about what applications we can use. And of course, everyone has been hearing about I love sports. I love playing sports. I love watching sports, and I love watching NFL as well, but not as much as English Premier League. Go Manchester United. Yes. But yes, all these contact sports where athletes are wearing helmets and stuff, and that helmet technology has come a long way. And it still has a long way to go to get, everything is going to get optimized, keep getting optimized. So do you think these, these engineering companies who are coming up with these top level technology are using tools like, what we are seeing in our screen right now?
Yes and no. I think a lot of still rely on physical prototype and also experiment with material and test that and do some clever designs. For helmet and protection, it's a constantly development and improvement in this area. But damping and material models need to be quite detailed, and I think we have the really good tools to do that. I think there's a lot of simulation that can be more used in those companies for sure.
Right. Matthias, I've got one question for you. Our viewer Sean, he's got a question. So when we are in that one animation that you showed us regarding the snowball, are you defining any specific contact conditions between those individual particles, or no. How do you set that up?
It's quite easy. It's kind of a viscosity and density. That's it. Okay. So it's kind of using those settings. Now, also the size of the particle, that's something that is very, very big here. So it's not behaving like a fluid. It's more like a snowball here in this effect. But it is just 2 settings to get this. And the trick is to use the elements types, the SPH. It's called the smoothen particle hydrodynamics. It's a mouthful to say that. So that's kind of bringing fluid into the structures for that. Otherwise, we use like a shell beam solid elements for that.
Got it. Yeah. Got it. Hopefully, this is your question, Sean.
Just to be a little bit wrapping up on helmet. I have a lot of videos with bloopers. I maybe I should do a blooper at the end of the year. So here's a video with I tried with some ice. You can see it's kind of rolling. I was trying mapping the iris on top of your globe, but I don't think we support it. I think I need to put it on a part or something there. So that's why it goes like that.
And to be honest, in reality, that's what's going to be happening too. Because if I get smacked with a big ball in my head, my eyes are going to go left and right. So
maybe it's not too far.
Pretty accurate, if you ask me.
Yeah, that's how you feel. All right, next, Bruce. So in SOLIDWORKS simulation, we cannot do failure or make things break apart. But with Abacus and the structure mechanics engineer, the material setup could include damage and failure. So then I introduced Bruce Lee. That's his alter ego with the red bandana on that, or band on that. And then I got really excited. I mean, can we break things apart? Let's make a cooler video. And this was kind of my first run at having some metal and some old.
So over here, we're seeing a ball going through multiple sheet metal pods, seeing if it's going to reach Bruce or not.
Yeah.
Or even if there's a flying component I see of.
Yeah, it's breaking apart. So.
Breaking apart and can smack Bruce on the head.
Yeah, I didn't record the full length of it, but that will be the impact of that. And the cool thing with the explicit solver that I use here is that you can slow things down and really see things in slow motions. And that's something I often see simulation videos is kind of 5-8 frames. It's very what do you call the English word? Study. It's not smooth. So I think this is about 200 frames or something. So you can really slow things down a lot with explicit solver, which is great.
Great. Let's see. Okay, it might not be. I'm not sure if the video was showing, but okay. Let's look at the next one. Oh, now this is my favorite Bruce version, the soccer.
Yes.
I love football. Like I said, glory. Yep. Manchester. So let's see what we got over there.
Yeah, so this was for the World Championship. I can see there's no colors, so there was a problem with that version, so I didn't have any colors, so it's back on. So here we got Bruce that is hit in the stomach with a football, and the clothes I did myself because I exported Bruce as nude. I have another video here with Bruce with no clothes and at a good angle, so we don't disturb anybody. There's nothing to show really, but so exported Bruce as nude, and then I designed the clothes on top of that. So we got a soccer with that.
All I can think about watching this video is the final between France and Italy back in the day, and I just want Zidane, another Bruce in there. We can call him Zidane, and let's recreate that. I'd love to see that, but no. But this is great. Like all the animations and these cool videos that you're showing us. I want us to take a second to see what applications our users or our viewers can think they can apply, when it comes to, let's say, the frame, the helmet, or, the soccer. What do you think that you guys can apply these applications to when it comes to your day-to-day life or even in your product development process? As Matthias shows us some more, please add some pointers in the chat if you guys can. And we'll take a look at that.
Yeah, and I like to hear some challenge for Bruce or environment to put him in a situation to explain it. Maybe with some fun twist, but
that's great. That's a great point. Yes, we would love that as well. So in the chat, throw what you want to see Bruce go through, and please be creative and not dark.
No hard feelings. Bruce will stand. I'm thinking to make him bleed. I think I need to do that. So there might be some more emotions coming up. Speaking about emotion, I did some with Flow also, interacting with Bruce. So he has emotion, and here he's crying a little bit. From joy, I would say, not from pain.
Joy of helping us. He takes all the stresses and all the loads and the forces upon it to give us a great product. So thank you, Bruce. We appreciate your hard work.
Yes, and more coming.
Yeah, Matthias, I'm very curious of the last slide that you have over there as well. What are we looking at in there? That seems very interesting to me.
Yeah, this is my latest, and I put a little bit more work into Bruce's version. So this is him in a new position, and the Bruce model here is a fully solid model. I removed his teeth and the mouth, what's interior there. So Bruce with the football was actually a shell model, a shell mesh. I use kind of the surfaces with the thickness, but this is a full solid model. And I also had put on some very nice new shoes. He's very proud of that. I should mention that. So this is kind of hitting a rigid wall, and see the reaction of that. Now, the material is not human, of course. And then I changed the wall into a thin aluminum sheet metal part, and he's going through that and see how it breaks. And I say, this is not I do for my working hours. This is kind of a little bit of my spare time. So I'm not, I do this for fun and to learn new stuff. So I can do Bruce videos all days, but that's not really my job. And I have a hard time showing off that to my girlfriend, saying that, is that what you do for a living? I'm like, no.
I know that feeling. I know that feeling, Matthias. But as a fan, I am thankful for all the Bruce videos. When you put it out there, I am the first person to look at it. I'm like, yes, Bruce is back. So I get excited, and I'm extremely thankful for Bruce and your hard work, where you share the gospel of simulation with us and our viewers. Do you have anything else that you would like to share? Because I think we're nearing that time, so we can also wrap up. But if you have something else to share, would love to see what else you've got for us.
Yeah, I have I just made a Bruce video today that is going to come out in the Easter, but I can show you guys that. Of course, Easter is. You see my screen there with the egg?
Absolutely.
Yeah. So this is my new Bruce Easter theme, and see how it goes. Oh, I need to play it.
All right, this is live. No one has seen this. This is the first.
No, this is world premiere. Yeah.
We are lucky.
I've got some S-page elements, and it's cracking also at the same time.
All right.
You can see this slurry. This is kind of the question about the effect. So this is kind of a bit more slurry settings, a little bit higher viscosity, and then it's kind of binding the particles in a better way there. There's also
exactly like how the albumin of the egg and the yolk will act, right? The little slur will be all over your face. Okay.
Yeah, it is actually an egg yellow in the middle. I didn't change the colors, but I would like to do that, and probably more eggs coming to Bruce as well. So.
Great. We can't wait. This is exciting. Bruce in the Easter egg fight. This is great. Yeah. Matthias, thank you so much for, taking time out of your busy
I have one more thing.
Yes, please.
Yes. So just my final words is that I think as a mechanical engineer or engineer in general, I think simulation is really bringing you as a superpower to your engineering work, because it's a tool to see through things. You get an X-ray vision. You get a thermal vision as well to understand the temperature and temperature distribution. You can shrink yourself. As I say, you can go inside your design to really experience from inside and out. You can control wind, like wind tunnels, control fluids and understand those, and also control time. As I said, you can see things in slow motion, very, very rapid events. You can really slow down and really understand what's happening there. And the big one is to predict the future. I mean, how much wouldn't you pay to predict your future? And with simulation, you can do that because you're virtual testing it, and it's a real money saver. So I'm surprised that not more have invested in these superpowers, because this is simulation for me, and that's my final words. Thank you.
This is a great point, and I think you bring a fantastic point as well, where simulation does bring superpower to engineers to make sure we are designing in the correct format, like we're going in the right direction without having to worry too much about it. So So that itself, as a peace of mind, it's important as a design engineer, So simulation does bring a lot. And Intel, what it does is, of course, it's saving you cost and time and effort.
Yeah.
In the end, that's what it boils down to: saving cost, time, and effort. So no, this is fantastic. And I think the more we talk about simulation with our users, with our viewers, the more we spread the gospel of it, the more people will know about it. So I think that's one of the reasons where, we're seeing quite a big influx of people adopting simulation now, and it's just going to continue to increase because, who doesn't want to have a superpower, right?
Yeah.
So,
yep.
So no, this is fantastic, Matthias. Again, since we're nearing towards the end, I can't thank you enough.
My pleasure to be here.
Coming on and sharing your knowledge, showing us a glimpse in this power of simulation and why it's important, and of course the superpower that it brings us. So of course, we'll catch soon, and thank you again.
Thank you for having me. Thank you.
Yeah, absolutely. So for all our users, if you guys liked what you guys saw today and Bruce and simulation, please make sure to like and subscribe our new channel, the 3D Experience Works YouTube channel. This definitely helps us a lot, and you get access to all the brilliant content that we produce, and of course you will be in touch with Bruce on a very regular basis. So yeah, that's that. So as for what we have for you guys next week, well, we all went to Nashville to attend the 3D Experience Works World, and it was a fantastic week of collaboration with teammates, and what's coming next and this and that. So our next week's episode is structured around what you. So if you didn't attend the SOLIDWORKS or 3D Experience Works World, you get a chance to watch our session next week, and it's going to be best of what you've missed in the 3D Experience World 2023. So this will be airing on March 23rd at 11 a.m. Eastern Standard Time, and we'll be talking all things that made this year's conference brilliant. The general sessions, what's coming up new, and so much more, and then special announcements as well. Yeah. So I'm excited for it, and we can't wait to see you guys there next. So it's great to have you over here on this episode of Lights Design with Matthias Robertson. My name is Ronit, and I was your host today. It's lovely to have you all, and we'll catch you next time. Bye-bye.